This is part 4 of the chapter Arithmetic Progression of Standard 10th. Now here we'll be doing something different. Now generally we have found the nth term from the beginning. Now there are some sums where you have to find the nth term from the end of an AP. Now if you want to do this, there are 3 important steps, which is the one. So first is you just reverse the AP. If your AP is say 3, 5, 7 and all that, you just reverse it in such a way that the first term becomes the last term and the last term becomes the first term, because when you are reversing it everything changes. That is the first thing. Second thing is you find the common difference of the new reverse AP. Then the third step is you simply find, if they are telling you the 10th term from the end, you just find A10, because now remember you have reversed the AP, and if you want the 10th term from the end, it is the same as finding the 10th term from the beginning of the reverse AP, but using by the same formula, an is equal to n plus 1 minus a plus n minus 1 into d. Now whenever the result is achieved or got, what we have to do is we have to write the answer as it is the nth term from the end of the original AP. So the statement should be perfect. So these are the 4 steps which we have to remember. These are very easy steps and it's a very easy way of finding the nth term from the end. So we will try to do 1 or 2 sums on this. So this is the first sum. Find the 8th term from the end of an AP. So the first AP is given to you as 17, 14 and up to minus 40. So what is my first step? The first step is on reversing the AP. On reversing the AP, what do we get? So what is that? 14 minus 3 is minus 3. So we will get minus 47, minus 37 and so on. Then 14 and 17. So now we will find all the details for this. So A is the first term is minus 40. What is D? This is the second term minus the first term. So this is minus 37 plus 40 means D is equal to 3. Now we simply have to find the 8th term from the beginning, because now we have simply reversed the AP. So if n is equal to 8, then an or a8, we have to find the 8th term. So a8 will be given as a plus n minus 1 into d. So this becomes minus 40 plus 7 3s are 21. So it is minus 19. So now the statement has to be written in such a way, therefore minus 19 is the 8th term of the AP. 17, 14 is to last is minus 40. So when you are writing the statement, please remember that you have to write it with respect to the original AP. So let's go for one more. Find the 15th term from the end of the AP 3, 5, 7 and the last term is given to us as 201. So if we see, the difference is 2. So when we reverse also it will be the same, but only it will be minus 2. So on reversing the AP, so this is always our first step. This way things will be very easy. On reversing the AP, what do we get? So it is 201. Then the difference was plus 2 here. On reversing it will be minus 2. You should have some idea. Then it is 9, then 7, then 5, then 3. So now we have all the details with us of the reverse AP. The first term is A, which is 201. The difference is 199 minus 201 means minus 2. And we want the 15th term. So n is equal to 15. Therefore I will put the formula of an. So it is 201 plus 15 minus 1, 14 into the difference is minus 2. So this is 201. 15 minus 1 is 14. 14 into minus 2 means minus 28. So I will get A15 as 173. Now, when you are writing the statement, we will write therefore the 15th term of the 15th term from the end of the AP. We have to mention the original AP here, 357 up to 201 is 173. That's your answer. So this is how we find the nth term from the end in an easy way. So the next topic which is there for us is the sum of n terms. Sum of n terms means we have to add up all the terms. Before this we were just finding the AP, we were just finding which is the nth term, we were finding which is the nth term from the end. Now we come to a stage where we should know the sum of all the terms, any number of terms of an AP. Now in this case we should remember that as we know that APs are of two types, one is infinite and one is finite. So we will be having different formulae for finding the sum of the n terms in case of infinite and finite. So let's see what will be the case in case of an infinite AP. So if the AP is infinite, there is no end. So we don't know how many things, but we can surely find the sum of the first n terms. So if A is the first term as usual, D is the common difference as usual, and n is the number of terms which are required to be added up. If that is there, then the sum of the first n terms is given by the formula n upon 2 into 2a plus n minus 1 into d. Now this is in the case of an infinite AP. Now what will happen in the case of a finite AP? Now remember, a finite AP will be having some limited terms, 10 terms, 20 terms, 50 terms, 100 terms, whatever it is. Now in the case of a finite AP, you know the first and the last term. So knowing these first and the last term makes our things easier. So we will use the simpler and a much modified formula for this. Now suppose the first term is A and the last term is L. Suppose it's L. Now if I want to find the sum of all the terms of an AP, then it is simply Sn is equal to n upon 2 and first plus last term, A plus L. So this is how it is a much simplified formula. So let's go and see some sums on this. Now these are problems on finding the sum of the n terms of an AP. So we will start with very simple ones. Find the sum of the first 15 terms of an AP, 7, 11, 15 and so on. Now if you see, this is an infinite AP. So accordingly we will be using the formula for infinite AP. But before that we will just write down the details. So the first term is 7. Then the common difference is 11 minus 7, it is 4. And what is our n required? It is 15. So we want the sum of the first 15 terms. It is written as S15 is equal to 15 upon 2 into 2 into A, that is 7, plus n minus 1. So this is 15 minus 1 into D is 4. So this is 15 upon 2. 7 2s is 14 plus 15 minus 4 is 14, 4s are 56. So this becomes 15 upon 2, 54, 56 plus 14 is 70. So this gets cancelled, 35. So 15 into 35 will do 75 for 15, 45 and 7, 525. So it is 525. So therefore we will say the sum of the first 15 terms of the given AP is 525. We will go for one more sum. Just say this. Find the sum of the first 30 terms of an AP whose second term is 2 and the seventh term is 22. So this is a little different type of sum. So we have to make two equations to find A and D because nothing has been given. So we will just start taking the data. So the second term is 2. Now the formula for the second term is a plus 2 minus 1 into 2. We neither know a nor we know d. So this becomes a plus d is equal to 2. So this I will write as equation number 1. Now we go for the second one, that the seventh term is given to us as 22. So writing it in the formula, we will write seventh term means 7 minus 1 into d. So the second equation is a plus 6d is equal to 22. So then solving equations number 1 and 2, this is just like linear equation in two variables. So elimination method. So I will take the first one, the bigger one up, and I will take the smaller one down. So it is easy for subtraction. So a minus a is 0, 6d minus this is 5d, 22 minus this 3d. So 5d is equal to 20. So d is equal to 20 upon 5 means 4. Then a plus d. So a plus 4 is equal to 2. So a is equal to minus 2. So now we are having the first term as minus 2 and the common difference as 4. Now we will find the required 80. So when n is equal to 30, the sum of first 30 terms. How will it be given? So it is S30 is equal to n upon 2 means 30 upon 2. 2 into a is minus 2, so I am putting it bracket, plus n minus 1. So it is 30 minus 1 into d, so the common difference is 4. So now 30 upon 2 means 15. 2 into minus 2 means minus 4. 30 minus 1 is 29 into 4. 29 into 4 is 116. So we are getting 15 into 112, which is nothing but 1680. So we will write a statement. Therefore, the sum of first 30 terms of the given AP is 1680. Thank you.